Okay, so I've got a BLDC servo motor drive with precision speed regulation, which is exactly the board that is on my hand right now, and we will test a new one that come like this in a fancy nylon anti-static, and we will try to see if it is working. So by this document we have that it is controlled by microchipped microprocessor, which is PIC 16F873A, and another MC3033, and component blah blah blah. And okay, I have here all the connections, which I can see 12 to 15 volt ground, and we have on the other side motor coils, ABC, Hall sensor, plus 5 volt ground, and sense ABC. Okay, and another data, and we have a lot of data. Okay, we'll skip all the data and come to how do I need to connect it. Okay, so let's see if I have another data about this one. Okay, just a second, trying to see if I have some other data. Okay, I have something else, which is this file, which is the board routing. Okay, so by the data they said that it is from 12 volts. Here there is something else, you can see 24 volts. This is one page with the connections. So we will try to find out if this is working. So I have here the board, a new board that we will test, and motor, 3-phase motor with Hall sensors, which I've done some extension in order to be able maybe to check the signals in my scope, look at it if we will need. And okay, let's start. So I'm opening this one, and we will connect the motor with the extender that I've made. Extender, exactly same wires, of course, just extended. Okay, so I'm connecting it, and let's test it. Okay, I've connected it, as you can see, and okay, about starting it up, no problem. I have here a wiring. What I need to do is supply voltage. They said 12 volts, here I see 24. I will start from 12, and I have two buttons, enable, which is enable and disable, and probably the potentiometer is the speed control, which is from 300 RPM to 4700. Okay, so let's connect it and see what we have. Okay, so I did all the soldering works, connected everything according to the datasheet PDF that I got. This is the start, this is the stop, this will be the speed, and I've checked that the power is of course the power on the capacitor, so I can connect directly power to the capacitor. And just in case, because I've got also hex file, I've connected pkit 2, so I will be able to burn new code and also check the datasheet, and the connector is not one-to-one connected to here in order to burn a code. So I did all the flipping and everything, and again this is a new board, so I've not changed yet anything, and let's check if it is working. So I will put 12 volts as written in the document directly to the capacitor with a limitation to 1 amp in order not to blow up everything, and additional 1 volt to the speed. Okay, this is the speed control, so I've limited it. It should be between 0 to 5 volts, so 1 volt I think it is okay. So let's power everything up. I will start with the 12 volt. Nothing is exploding yet, and now the 1 volt, and let's see what we have. The motor is not working, it shouldn't. The start should start it, and nothing happening. Nothing is happening. Okay, so now let's read and see if we have data on the microchip. Before I do this, let's try to up the voltage, because I've seen something. It was also written 24 volts, so let's make sure it is. Maybe 24 volt will solve it. So I'm changing the voltage to 24 volts. Nothing is exploding. Okay, let's recheck before trying to play with the software. Nothing happens. Nothing happens. Okay, so let's now try. I will stop the power. Try to read data from the microchip. Okay. Okay. So let's connect it according. I again need to flip everything and blah 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 blah. Okay, so this board is not working as it came. So I'm doing now all the reverse engineering, trying to solve it. Okay. So let's read. Let's read. Okay, so I've connected the cable, okay, because I can read something. And also not reading. It also identified the peak number, which is 16873. I think that was written. What do I see? On the first byte I see something in it, and then it looks like it is empty. Oh no, it looks like it is empty. Up. Wait. We have software here. We have something on the upper memory. Okay, so the chip is not empty. There is a software, and the software is not working. Let's try to upload the data that I got from the seller. Let's try to do it. Why they are not doing something that go. Okay, so I can try verify. We'll compare between the two files to see. There it goes. They are not the same. They are not the same. Okay, just a second. Okay, so now I write the new files that I've got. Okay, I will verify that the files that I wrote is now the same that is written to the board. Okay, verification successful. Okay, so now I will disconnect the programming cable and then try to run it and see what happens. Okay, so we've got everything connected. I will power now my power supply. Start with the 1 volt and then the 12 volt. Okay, nothing is exploding. I will try to run the motor. Button is doing nothing. Also this one. Okay, I will try to change the voltage to 24 volt, although in the datasheet it was written that it is okay with 12 volts. Yes, but not on this one. On power supply number 1, of course. Okay, nothing happens yet. Let's try to power it up. Okay, the motor is spinning. As you can hear, it is spinning clockwise. Okay, so it is not working on 12 volt as written. The software is incorrect, so I had to burn the software that I got. Let's see if the stop button is working. The stop is working. The on is working. Now the third thing was that increasing the voltage should increase the speed. Let's see. At least this is working. Okay, I will try to put it on the same frame, both, and now I will move to power supply number 3 and change the voltage. Just a second. Voltage. We need to change the voltage, not anything else. As you can see, it looks like the speed is decreasing and not increasing. Yes, the speed is decreasing. .6 volt. It stops. Okay, about 2.7, and now it is anti-clockwise. So okay, so if I am above 2.7, so it is anti-clockwise, and if I'm below 2.7, so this is clockwise. So it is not as written in the document also. Okay, but I'm used to it. Five volt is actually the top speed, and also probably 0 volt is the top speed to the other direction. Again, now it is anti-clockwise. Let's change it to 0 volts. Yes, this is clockwise. Okay, so there were many things that are incorrect with this manual, so let's go over them quickly. First, okay, so the switch are okay. The voltage, you need to connect it to P7, and P number 1 is ground. You can connect the power on the capacitor itself. Also, you need to burn the new code, and in order to control, you have to connect 24 volts and not 12, at least on this motor. And another thing is that the 2.7 volt is not spinning, and 5 volt is maximum speed to one side, and 0 volt is speed to the other side. Another thing that I would like to check now before changing it and disconnecting everything will be something important. I will put it on the same frame, and this disconnecting the Hall sensor. Okay, this cable is the Hall sensors, and it's up. So you must connect the Hall sensors in order to, if you have a motor without Hall sensors, then you have a problem to connect it to this board. Okay, that's all. So we have it, everything okay. Thank you.